Now, in the previous video, I had alluded to something called the stability or convergence criteria of our solution. And I was talking about lambda, let's just write this, lambda being equal to some constant multiplied by our time step and divided by our spatial step, grid spacing. And what do I mean by convergence and stability? Well, what I'm essentially trying to say is that as delta x and delta t approach 0, our numerical solution should converge. And convergence is an important part of the partial differential equation criteria in order to help us set up our problem. Now, the stability of our solution is referring to the errors. So in other words, the errors at any stage of our computation are not amplified if we have a stable solution technique, rather they are attenuated. So for the explicit method, something that is a solution that is stable and convergent can be achieved by setting lambda being less than or equal to a half, or our time step being less than or equal to a half of delta x squared divided by k. Now, just because lambda is, say, less than a half, doesn't mean we're not going to have errors. In fact, what has been shown is that the errors actually oscillate when lambda is less than or equal to a half. So if we want no oscillation, we just set lambda to a quarter. And if we want to then minimize our truncation error, we just set lambda to being less than 1/6.